are live. My name is John, and I'm the science educator for Children's Museum Houston. And welcome to our weekly Geek Out, sponsored by our friends at Flint Hills Resources. And we're in a different location than we normally shot these weekly Geek Outs because the weather is beautiful and we're actually talking about weather. So we are located in our awesome eco station today. So we have our turtles in the pond, you'll hear running water, cars moving by, maybe a plane overhead, so we'll have a little extra sound than usual, but we'll be learning about the weather and enjoying this beautiful weather. So we're actually at our Genius Station cart. So this makes it so we are mobile. We usually use it inside to move little activities all around the room, but we figured, we'd go outside. So as we let some more people come into our live session today, I kind of want to break down kind of this new format of our segment because I broke it down last week, but just in case you're tuning in again and you haven't been here since November, what we're doing is we're going to start answering very specific questions. So these are questions that you guys send us. So there's a couple different ways you can do that. You can submit these questions either just to the comment section of our Facebook Live, or you can send us an email, and the email actually goes right to me at geeks@cmhouston.org. So if you don't want to post it on the live chat, that's totally fine. You can send an email to me, and then I'll talk with the other geeks that you've seen every other week, and we will come up with some cool experiments to answer these questions. So we are going to dive into this week's questions. They actually sent us two from Olivia, and they were related. So she was curious of how do clouds form, and why don't all clouds rain? So we're going to do a couple different experiments explaining these two questions, and then we'll talk a little bit about different winter precipitation that we might see in Houston. I don't know, it's pretty hot here, but you'll at least be able to understand why it's raining, or if we have sleet or snow, you'll be able to understand what our atmosphere is doing. So our first experiment is going to help us explain how clouds form. Now this is a common experiment that a lot of people do, and it is one of my favorites, and it's called Cloud in a Bottle, where we are going to do exactly what the title says. We are going to try to make a cloud in a bottle. Since we don't have any clouds in the sky today, I was hoping we would be able to reference some, but since I don't have any to point to, we'll have to make one. So this experiment's pretty simple. We're going to use your standard bike pump. So just like you're pumping up your tire, we'll be putting more air molecules into the bottle, and the liquid that you're seeing kind of jiggling around there is actually rubbing alcohol. And because we're using rubbing alcohol, I'm going to put some goggles on because we have to have some safety when doing some cool experiments. So the reason we're using rubbing alcohol is it will be a faster reaction compared to if we were using water. So we're going to be tossing around some water cycle terms today. And so rubbing alcohol evaporates faster than water vapor, liquid water. And don't worry, we'll be tying all these experiments into exactly what's happening in the atmosphere. And so the reason this experiment's so cool is it's the same thing that happens outside. It's just a little bit quicker. We're not waiting for a cloud to grow. So I'm going to plug this bottle up, and we're going to start increasing the pressure. So when I'm doing this, you can envision me pushing the air molecules down. I'm compressing them. And when that's happening, they're bumping into each other a little more. They're warming up. And so when I reach a higher pressure, I'm going to release it. And when I release it, you're going to hear a pop. And that's the air escaping. And we'll hopefully make a cloud. Let's see. So in 3, 2, 1, we were able to make a cloud. Now we can let this cloud out into the sky. We'll let it back out. So that loud pop that you heard was the air rushing out of the bottle. And when that happens, the air is actually expanding. So it was warm initially, it was compressed, it was bumping into each other. When it spaces apart, they're not bumping into each other as much. they're actually cooling down a little bit. And when that happens, they start to slow down until they will go from a gas to a liquid. So we were able to see a liquid cloud droplets form here. So this happens outside, but just a little slower. So you can see the sun beaming on my face right now. Well, what happens is that will heat up water, that makes the water molecules start moving around some, and it causes evaporation. Well, when that happens, the air starts to rise, and it does the same thing in expanding. It's just a little bit slower. And so when it expands, that's where we'll get a nice cloud layer and then hopefully rain. So we'll learn now why all clouds don't rain. So you'll see on some days you'll have these nice puffy white cumulus clouds, but no rain. Now let's learn, I'm gonna kind of shift all my materials around here. Let's learn why not all clouds rain by using just a few simple materials. So I have some water that I've dyed with food coloring. Turn the label there. I have a little pipette that's gonna help me count my drops out. And then we have our important piece. This is the cloud. So you can tell this white puffy cloud, this one doesn't have a lot of moisture in it yet, but we are going to add that. So for this experiment, if you're following along at home, what we need to do is we need to make a guess at how many little droplets this cloud will hold. So if you think it's less than 20 drops, give us a thumbs up. If you think it's maybe 20 to 50 drops, give us maybe the heart emoji. And then if you think that it can hold a lot more, give us the laughing face. So maybe 50 to 100. And so I'm gonna start counting, and I'm gonna be rotating my cloud around, and I'm gonna quickly count, but if you're following along home, take your time, make your hypothesis, definitely make a guess, and as you're doing the experiment, you can always adjust it. If you have more, if you guessed 5 and you counted to 10, well, think, well, maybe how much could this hold? Maybe 50. So let's quickly go through this, and we'll start adding the water. Now, what we're looking for is it will eventually start to rain out of the bottom, and we'll talk about exactly what that point is called. So I'm gonna fill up my pipette, and I'm gonna start adding my droplets. So I'm at about 5, and sometimes the droplet will kind of sit on the cloud and roll off. Now that doesn't count as rain, it has to be absorbed. So it'll slowly start absorbing. We're at about 10. We're gonna try to speed this up a little bit. All right, we're closing in on 20. So I know one of our guesses was 20. So now that we're past that, what do you guys think? What do you guys think it will be? You guys can always update your answer, and it's getting absorbed down at my finger. Sometimes I think the food coloring affects the absorption a little bit. That could be a future geek out. Okay, so you can see it's starting to get dyed blue. We are closing in on 50 here. We're gonna put a lot here, let that get absorbed. It's starting to get a little denser. So this one will put us definitely past 50. We'll start moving towards 75. All right, we're at 60. All right, we're at about 70. I'm gonna fill this back up. So if you're following along at home, definitely keep counting. We'll try to make it rain shortly. And so as this cloud is filling up, it will reach a saturation point where the cloud cannot hold any more liquid. So the cloud droplets will be big enough to actually fall out as rain. So we are closing in on 100. So if you gave us a laughing face because you thought there's no way it can hold more than 50, we are up above 100. And why this experiment is so good is because the rain clouds that are up above our head, or actually just clouds in general, a cumulus cloud can hold about 17 million gallons of water just floating above your head without it even raining. Oh, that rain or did it roll off? We're very close now. Let's see, is it rain? I think it's raining. Now, we are somewhere around 125, 150 drops. We're gonna add a bunch, see if we can really make it rain. There we go. So our cloud is fully saturated, and we are now getting a little Houston storm on a very clear day. So we'll let this rain kind of come out. So if you don't have a pipette at home, you can always kind of use like a teaspoon, tablespoon, and just keep track of how many you're adding, and you can do kind of a makeshift version of this experiment at home. So another adaptation you could have is, what if your cloud was not quite as compact? What if it was spread out? Do you think it will hold more water this way or less water? I don't know. You guys will have to test it out and let us know. You can always send us your results. If it's not a question, you can send your results to geeks@cmhouston.org. That'll come to me. I'll get to see some of the experiments you guys are doing and following along. So now that we have learned how a cloud forms, we've talked about why not all clouds will rain. What we're going to end with is just a little explanation of different types of winter precipitation. So I'm going to take these off now that we're not messing around with dangerous water. And made a little chart, and I say I made it. My wife drew this for me. She tends to draw all of my whiteboard drawings. So thank you for bringing all of my ideas to life. So what we are going to talk about is 4 different types of precipitation. So we've been throwing around these water cycle words. So we've talked about evaporation, and condensation was when we made the cloud, went from a gas to a liquid. And now in this case we're going to talk about when the cloud is formed and it's saturated and that precipitation is now falling. And so in the winter, typically the precipitation will start out as snow if it is cold enough. So to have this frozen state, you have to be at 32 degrees Fahrenheit or 0 degrees Celsius. And so in each of these scenarios, we have to think about that the atmosphere is cold enough to support snow. So this is definitely not right now, since we have 70-degree weather here today, but a couple months from now, we may be able to support snow here in Houston. So in each of these scenarios, we're starting out with snow, and in Houston, this is going to be your typical scenario, where you have to think about this as between the cloud and the ground. This area is our atmospheric layer. So depending on the temperature of that atmospheric layer, you'll get a different precipitation type. So if you have a deep, warm layer all the way to the surface, your snow will actually melt and go from a solid state to a liquid state, and you'll get rain. So this is usually what happens when it's that cold, nasty 40-degree, 35-degree rain that we might get here in Houston. This is the scenario that's usually happening. Now in these other two that have some warm air that you can see there, it's still starting out as snow, but it's melting into rain. But in this scenario, we'll get freezing rain if it is below 32 degrees or below at the surface. So a lot of times this will happen in the early mornings when our surface layer has cooled off and you have this cold chunk that can actually refreeze the rain. So when you get to sleet and snow, this is where you start to see the white stuff falling from the skies. And so in this case, their warm layer is thinner, and so when the snow melts, it actually has a chance to refreeze before it reaches the surface. So this is usually when you'll see kind of the white pellets that are kind of falling. It's not fluffy white snow. It's almost it's a little more icy. That is what's called sleet. And now our favorite precipitation state is snow, and you can see this little snowman there. And it doesn't happen all that often here in Houston, but don't worry, I'm gonna geek out whenever we do have snow. We'll dedicate a geek out to snow again. But this is where you don't have a warm layer, and it is just 32 degrees from where the cloud is producing snow all the way to the surface, where it can then kind of collect and you can start throwing snowballs at your brother and sister. So now we have covered how clouds form, why clouds don't always give us precipitation, and then we've kind of given a teaser for the winter, and hopefully we can come back to these and do some other wintry experiments down the road. So don't worry, I will come back to weather anytime I get a chance. So for the next couple weeks, as we get into this holiday season and lights are going up and the trees are going up, we are going to be making ornaments in the next 2 geek outs. So Jason and Andrea, who you've seen in previous videos, they're going to be teaching you different ways to make some last minute ornaments that you can hang on a tree, a doorknob. I even hang them in my car. And so they're going to be making them out of plastic, and Andrea is going to teach us a little bit about crystallization and teach you how to make a different type of ornament right before the holiday season really gets going. So again, my name is John, coming to you from Children's Museum Houston. Want to give again a big thanks to Flint Hills Resources for sponsoring the Genius Station cart, for sponsoring Science Station, How Does It Work, and these weekly geek outs. And since we're outside, you can probably hear a distant car going, but go outside, enjoy this clear weather, and when we start to get some more precipitation in the winter, don't worry, we'll come right back. Again, if you guys have any questions, send them to geeks@cmhouston.org, and we will see you on some future videos. See you later.